The data center business and its footprint has grown at a very fast pace over the last decade. It's all being driven due to technologies, more specifically digital transformation, which in many cases, countries like Singapore are driving it at a government level to make citizens' life more convenient. Is also driven by technologies. Cloud helps customers to move to a platform which is scalable, more secure, more flexible, on demand available. And so a lot of IT, which was previously in-house, on-prem, at enterprise level, is all now moving to cloud. And what this is doing is it is creating data center footprints, which not so long ago were in tens of megawatts to now hundreds of megawatts. What used to be a footprint of a country is now footprint of a campus. And so if you are a utility supplying water or electricity, this is a completely new challenge. Most industrial areas are zoned to have certain capacity per square meter, per square kilometer. And when you start building campuses of 300 megawatt, 400 megawatt, the utilities don't necessarily have a way to solve that. Also, from a pure power perspective, utilities take years to upgrade their grids, whereas the data center growth is unprecedented. The challenge differs from country to country. There are certain countries which are abundant in power. Certain countries have better weather. Europe, Northern Europe, some parts of the US, North Asia. Whereas some, where we come from, are ridiculously hot. Water has become a challenge. Not so long ago, to make any infrastructure efficient, especially on the cooling side, water was seen as an catalyst or an additive to reduce energy consumption for cooling. But at that time, the data centers, like we mentioned, were a few megawatts. When you scale that up to hundreds of megawatts, you now are looking at millions of gallons of water per data center per day. It's not a sustainable situation to be in. And so all these challenges are kind of in many ways setting up opportunities to solve these problems, especially because the data center growth, we believe we are 1/3, 1/4 of the way. There is still a lot of headroom in terms of data centers.
You mentioned a lot of the issues there and challenges. What kind of innovations in technology are you seeing or bringing to the market to help solve these challenges?
There are certain innovations that are purely driven because of the technical research that is happening. Then there are certain innovations which are driven simply because of the demand, the pressure to bring innovations in place. If you look at the whole data center life cycle, we are looking at the power consumption being so huge. We are looking at how do you consume more green power. So that is the first part of the data center in terms of green power, renewable power, because you're talking hundreds of megawatts. For renewable power, you look at sources like wind, solar, which are not necessarily consistent and predictable. So that opens up this issue of how do you create a sustainable, reliable, renewable energy source. If you are in Iceland, you have geothermal power. The whole of the country is 100% renewable energy. But if you come to any other part of the world, this is a challenge. So there are multiple innovations that are happening there. On the technology side, there is a whole microgrid play that is out there. You see, data center is the only consumer in the industrial world that has more power than what it consumes sitting idle on the data center. So if you have a 100 megawatt data center, you probably have 150 megawatt of diesel sitting with 20, 30 hours of fuel. You have equal amount of UPSs with 15, 20 minutes of battery. So there is innovation in terms of how a data center can start going from being a consumer to a prosumer. You also are able to produce energy and put it up in the grid. The sheer play of demand is also driving more investments in the renewable energy. So solar, wind energy, coupled with energy storage systems, are helping the grids, the suppliers, to provide more continuous, reliable power. So that's on the source side. If you then look at how power flows through the data center, most of the power is driven at a medium voltage level. whereas most of the IT runs at low voltage. And so there are multiple power conversions. UPSs tend to operate at low voltage. At low voltage, the currents are much higher for the same megawatts. You basically have higher I-square losses if you are moving closer to the load. If you were to move the UPS towards medium voltage, your losses in the UPS go down. I know this is incremental benefit, but every percent of energy is important now. So the other innovation that we are looking at is medium voltage UPSs that provide the continuity at a higher voltage, therefore much lesser losses. And so the electrical distribution losses drop by another 1-2%, and that improves your efficiency. So that's on the power side. Other innovation here is using AI, machine learning, blockchain technologies to be able to source power based on how green it is, what's the tariff, what's the availability. In many countries now, multiple power sources are available. You cannot manually move power sources by the day, by the hour, by the month, but you can program platforms to automatically negotiate through blockchain, validate, sign off, transfer power, so that you are always using the most optimum power, the most green power, the most cost-effective power at any point in time. If you then look at heat rejection and heat extraction, most of the data centers and most of IT infrastructure till date has been operating at sub 10 kilowatt per cabinet. Clearly, more GPUs, more TPUs, more processing is driving up the demand within the data center. Also, you have newer chipsets that can do more in terms of compute and therefore consume more power. So today, 10, 20, 30, 40 kilowatt per cabinet, even 100 kilowatt per cabinet is out there as an application. This requires a very radical way of thinking. Most of the heat extraction, simply because it's very easy and flexible, is based on air. All servers are air-cooled as of now, except some of the higher density ones. When you cool these servers through air, the delta between supply and exit air is quite narrow. So the rejected air is hot, but not hot enough. And so the ability to recover this heat, reuse this heat is very minimal. On the other hand, if you allow the workloads to operate at higher temperatures, if you allow the heat rejection to be at higher temperatures, there's an opportunity to reuse this heat. And liquid cooling allows that benefit. Clearly, liquid cooling, by virtue of its ability to consume less power, ability to reuse heat, is an area of innovation where most companies are working on. Even in the air-cooled area of cooling, there are too many variables. Water temperatures in the chill water circuit, fan speeds, compressor speeds, temperature of chill water, temperature of exit air. All of this can be varied, fine-tuned to extract further efficiencies from the cooling system. So use of AI, machine learning to optimize the air cooling circuit extracts further efficiency. So there's a lot of innovation happening in that space. Finally, there is still a big elephant in the room, which is embodied carbon. Most of the stuff we talked about so far is operational carbon, renewable energy, more efficient power, more efficient cooling. Clearly, less energy consumed, green energy consumed is low carbon. But what about embodied carbon? Most of the data center construction today is brand new construction. Most of it is concrete construction, huge amounts of embodied carbon. So there are approaches that are being used by different players, and there is no one approach fits all scenario. It's very region specific, size specific, place specific. So for example, repurposing buildings, repurposing warehouses, factories is helping customers and players to ensure that embodied carbon is much less. Using low carbon concrete or injecting carbon in concrete to further reduce the emitted carbon are technologies that are being used. At Huawei, we have pioneered what we call the complete prefabricated modular construction system. So this allows us to build data centers using prefabricated modules, which are construction steel structures, such a bolted steel structure system. Steel has about 70% less carbon as compared to concrete. By ensuring that most of the manufacturing of the modules is done in the factory, prefitting is done in the factory, reduces wastage tremendously.
Sanjay, thank you so much for sharing your thoughts with us today. I wish you the best for the rest of the day.
Thank you.